Say that we have the following geometric series from the previous video, and this time we want to find the sum of the first 3, 5, and 10 terms. For the sum of a finite geometric series, you'll often see two formulas that you use depending on the value of r, the common ratio. When r is greater than 1, you have Sn is equal to a r to the power of n minus 1 divided by r minus 1. And the other formula for when r is less than 1 is Sn is equal to a into 1 minus r to the power of n divided by 1 minus r. Now, it doesn't actually matter which of these two formulas you use. There's two formulas so that the numerator and denominator stay positive at all times. But you'll see that you can still use the first formula when r is less than 1 and the second when r is greater than 1. To prove this point, we'll stick to using the first formula for all our questions. So for our question, the first term is 128, so a will be 128, and r is half since the terms are decreasing by a factor of 2. Now let's have a go at part A. We want S3, which is equal to a, 128, into r, half, to the power of n, which is 3 minus 1, divided by r, which is half minus 1. Now you can see at a glance that both numerator and the denominator are negative, and these negatives cancel out, and that's why it doesn't matter which of these formulas you use in practice. Simplifying this, we get 224. Now part B. We repeat the same steps. We want S5, which is equal to 128 times half to the power of 5 minus 1 divided by half minus 1. Plugging this into the calculator, we get 248. Now for part C, you can pause the video here and have a go at this yourself. So S10 will equal to 128 times half to the power of 10 minus 1 divided by half minus 1. And if we put this into the calculator, we'll get 255.75. Now you can see that as the terms get bigger, the sum isn't getting that much bigger. In fact, it looks like it's starting to converge, and in fact it will converge. And this is called an infinite or limiting sum, which we will look at in the next video.